Okay, let's get started. Today, we are going to talk about the big data technology behind Double 11 Shopping Festival. And thanks for joining this webinar. And I'm Derek from Alibaba Cloud Academy team. And okay, first let's go back in 2009, and there's two simulated thing happens. It seems unrelated events. So the first one is the Alibaba Cloud was formed. At early that year, the Alibaba Cloud engineer wrote down the first line of code of Apsara system. So as the screen shows, this is the line code of the first Apsara. It is a it's just like a Alibaba version of Hadoop. It is a distributed operating system. In an office building without heat supply in Beijing early in 2009. And the other thing happens also in 2009. It is the first year of Tmall Double 11. So that year the GMV got 50 million RMB. So it is in that day, Tmall launched a sale campaign called Double 11 Shopping Festival, and nobody expect that year later they would be what they are like today. So in the latest Double 11 in 2018, so the GMA reached 213.5 billion RMB, the 30 US dollars. So it is the 27 increase than 2017, more than twice of the total sales of Black Friday and Cyber Weeks in the US. So it is not a success of Alibaba itself. In the back, so we have covered the region and the countries more than 200, and we have produced more than 1 billion orders, and we have more than 118 brands join into this shopping festival, and over 1,500 telecom carriers to help to deliver this shopping festival. And we have a logistic company to help to deliver your goods, and more than 200 financial institute to help for the transactions. So let's see from the technology aspect of Double 11. So it is a typical pulse computing. What does it mean? The pulse computing means if you're in the peak hour, the most orders happens in the midnight of the day of Double 11 from the 0 to 1 o'clock. So it is 5 times than the ordinary traffic in that day. So during during that hour, the maximum peak traffic is 291,000 order per second, and it takes 518 milliseconds to deal with one order, and that number is 250 times than 10 years ago. We have just showed in 2009. So you can see the chart, the traffic flow by the hour. That is from the 2018. So back in the end, we have successfully blocked 1.6 billion network attack, and we leverage the 10 million CPU cores. That equals maybe 10 data centers. So we can suddenly to leverage all of the resources to support the Double 11. And back in the AI and the machine learning, we are doing the 45.3 billion purchase recommendations made by the AI and the machine learning technologies. During that day, the customer service is dealt by AI is equals 586. That equals 586 day manpower. So it is not only one pulse computing happened in the world. So we have, beside Double 11, we have Olympic Games, we have Black Friday, we have World Cup. And if some breaking news happens, it will take use of lots of technologies to do that. So let's see. It is a long story talking about the technology back behind the Double 11. So we are only to pick one small point of the big data and the AI. So this is the max compute is the manpower which support the offline data processing back in the Double 11. So it will keep improving computing capacities. In the 2018 Double 11 serves 80% business and with 40% extra resources. So we can see some benchmark take by the 2008 and the 2018 and 2017. Sorry. So we are more cost effective than other vendors. So we are leverage the new SQL optimizers. If you are familiar with some database SQL engines, we are totally the cost-based optimizers. And these are the technical details. You can get the PPTs for reference. So the Blink is the for streaming technologies. So if we are doing the streaming process in that day, so in the big screen, we are showing the GMVs moving fast from time in the real time. So that is the Blink, which is the stream process engines in backend. So that's a much big topic when talking about the big data and even the technology behind the Double 11. So we are picking one small point of that. So let's considering from the workflows. When you are writing a code for your own business, so it may be something like this. You have some data and you have some tables. You have some data source. You want to import the data source into your data processing engine. Let's say you have some unstructured data in the FTP. Let's show in the left-hand side. You have some structured data in the RDS. So you want to import those two data from those two data sources into one, to join it into one table. And you probably do a join and do some other like group by or count something else. Then you get your final result. So this is a quite simple or small business workflows. So we're going only talk about the workflows. But in the real production system, like the Double 11, is more complicated than this. So this is some scheduling system or workflows in the real production environment. So it's quite complicated. So back into this simple one, you can define the workflow manually, like first do data synchronization and another synchronization in parallel, and then we'll join those two tables. You can even using the join and the job actions to draw these workflows. But when you deal with real production, real business got more complicated. It will not possible for you manually to do the workflows. So what are you going to do? So this is another production environment where from the Alibaba internal use. So you can see there's many jobs and each many tasks, and each task have many dependencies. So this is too complicated for the developers or even the product managers to do that. So that's rely on a dependency configurations. So we are going to introduce one small point of the technology which is related to the workflow dependency configurations. So the first thing is why we need the task dependency. We have already do that. So we have already explained that because the real production system is so complicated. Let's see some other regions to explain why we are needing this task dependency. And the second thing we are going to talk about is the overview of dependency working principles. And we are going to introduce 3 dependency configuration methods in the end. And the automatic passing is recommended. So we are going to using a demonstration to do that. First, let's see why we need this dependency working principle. So let's say you're writing some SQL statement, and to do your workflows, you probably write down some lines of SQL. And as your business grows bigger and bigger, you may write down more SQL statement and more code blocks. And so you need to copy paste to change the workflows because your business change. And that will bring some bugs because when you copy paste, it will make some error. And when you define the workflows, maybe you miss something in the backend, which is supposed to be in the front end. So that's the first scenario. It is poor flexibility, lack of decoupling. If you want to test what you have done, you may to rerun all of the code in this task. Maybe you want only to run some of the line of code, but you need to rerun all of the code because it is in one task. So in the new version of the Max Compute and DataWorks, it is supposed to you to using the automatically passing the dependencies of each task. So it using the output name for each task to define the workflows automatically for you. It will, if you have many tasks, it will not you to do that manually. So let's see a demonstration of that. For those, if you're not familiar with the new version of DataWorks 2.0, it will publish this next week in the overseas region. Now it is available in the China, South China, Middle East China region too. So we can create a DataWorks workspace or Max Compute project in that region. So this is the dependency configuration demo in DataWorks 2.0. First, we navigate to alibabacloud.com and log on with your Alibaba account and password to the consoles. And you choose the DataWorks and the DT Plus to log on to DataWorks console. The first thing is you're going to select one region and to activate the Max Compute and machine learning if you want, and the data integrations. So you input the workspace name and some other information you need to create a DataWorks project. So we provide two type of workspace mode. So that's something we will talk about maybe in the next series of class. So we chose standard mode in this DataWorks workspace. So this status is initialization, and where it will going to change after a while. So let's do a refresh. Its status will be normal. So we're going to enter this project. So this is the dashboard of the new version of DataWorks. You can see it is you can made up of solutions at the business flow. So the business flow means it's made up of bunch of tasks. You can create tasks in each business flow, and you may have several business flow in one solution. So if you have small business, maybe you can start with the business flow part. So first you can create a business flow, give it a name and description. So you can see in the workflow we can define some task. First line is data integrations in the middle left. You can see the first line is data integrations and data synchronized task you can create, and some circle statement, map reduce a task, and virtual node. Even the Python ODPS task that means you can write Python on a mass compute. And machine learning algorithm, you can also to do that. So this is a dashboard. We can drag some task into that. So first, we're going to create an ODPS circle task. We can drag this task, give it a node name. And we will create 3 tasks. They are all ODPS circles. Why we are going to create 3 tasks in this demos? Because we want to see the dependency, the automatically dependency done by DataWorks. So we are going to create 3 tasks to see after configuration if they can recognize each other. And we go into each task. It will give you some place to write down your circle statement. So we write down one simple circle statement, which we are going to create one table from another table. So you can see it have some relations, input table and output table. Let's go into circle in the task 2. We copy paste the first one and just change the table name, and we create a new table from the table the first task have just created. So we can see from this simple code that those 3 tasks have some relationship. That circle and score 2 and score 3 will rely on the circle and score 1. So these are the 3 tasks we have already done. In the real production system, it will more complicated than that. So we are just using this for demonstrations. We double-clicked, we go into one task and go schedule. So this is the schedule page. You can do some configurations. And in dependency section, there is a pass IO, input and output. So auto pass, you can choose yes. So we can see there are some output name. It is a table. The table 2 is some outcome from the first task. So this is from the first table, first task. We're just choosing the dependency into yes. So first we need to save these configurations. So you need to down to some version notes into the box. So it returns some arrow that shows the first, because the first task is create some table from the table is not exist. So we can deal with that to ignore the table 1, because the table 1 is not exist. We can remove input, so it will not pass in this one. So when you are doing this in your own environment, please make sure if you're doing this. So when you remove the input, it will show one extra code automatically generated in the first line. It is called exclude input table 1. So it will not pass in this input. So after doing this, we can to do the pass again. And you can see there is no upstream node. So we also need to save these configurations. There's another thing. If the first outcome dependency is not exist, you can use the workspace root node as is upstream task. So the task name will appear with the project name and the root. So we are done for the first task dependency. It depends on the root. And we go into the task 2. We are seeing that it's create a new table from table 2. And we'll do the pass, and it will automatically recognize the upstream node, so which is the table 2, and the output table, which is table 3. So we also save these configurations. And the third task, we are actually creating a new table from the table we have just created. So we'll also do the pass. Automatically, it will recognize this outcome, the output name, upstream node output name, and its own output name. So you can see there are some dependencies between those 3 tasks. So now we are done with configurations. We can refresh this dashboard. We can see some magic happens. So it automatically generates some dependency using this arrow. If you write down some like join circle statement with 3 tables, if let's say it also can recognize that for you. It will save much time when you have complicated task scheduling. So then after the configurations, you may save this workflow